Good morning, Pre-Alg students and parents, and any Math 6 students or parents who are happen to take a look. I want to take a look at a couple of the questions that seem to be missed by, at times, depending on what period it was, by at least, let's say, 20% of the class. Now, taking a look at this question in particular, this is where you had to both write an equation and then solve it. And remember, we talked about when you're writing an equation for these, a lot of you jump to, you know how to solve it, you know what operation to use, but then when you write the equation, remember, to solve it, really when you have an equation, you're doing the inverse to solve it. So when you're writing the equation, you're thinking about, oh, I'd use division to solve it, which you're probably right. But in the equation, you actually use the inverse, so you use multiplication. Or, vice, if the way you solve it, you're using subtraction, well then in the equation, you do the inverse, you'll use addition. So it requires you to kind of do a little backwards thinking. Teachers do backward planning. We develop the assessment, and then we create our lessons to get you to that assessment piece. It's kind of the same principle here. So looking at this, the Smith family spends an average of $450 monthly for groceries. Groceries account for 1/8 of their monthly costs. How much are their monthly costs? So again, we have to start thinking too. We have to start thinking to ourselves. What is this question saying? What's the words? What's the verbiage? So I know that they spend $450 monthly on groceries, okay, which I wish I could spend that little on groceries. Groceries account for 1/8 of their monthly costs. So right now I'm saying to myself, okay, so their monthly costs have to be larger or greater than what they spend on groceries. You can't spend $450 on groceries and that be more than what your monthly costs are. It just doesn't work like that. And I see that fraction, and I know the fraction is what threw us off. It's 1/8. So I don't know how much money they make or how much money they have or how much their costs are for a month, but I know if I were to split that monthly cost up, let's just say $1,000 for instance, and I split $1,000 into 8 pieces, one of those pieces is going to be groceries. I think of like a puzzle, or I'm sorry, a piece of pizza or a pie. So I don't know how much their groceries are, so I'll call that G for groceries. Now I know that an eighth of their groceries, or an eighth of their monthly costs, are spent on groceries. So that means I take the amount of groceries and I divide it by 8. Now all I know is that 1/8 of their costs is equal to $450. So there's my equation. Many of you wanted to multiply 8 by 450, which makes a lot of sense because that's essentially what you do. Because you say, hey, wait, 1/8. Well, to figure out their whole cost, I go 8 times 450. But remember, in your equation, you do the inverse. So that's why I'm taking their total cost, or their total amount of money that they make per month, and I just call it G because I talk about groceries, and I divide that by 8. Now, I need to solve for or evaluate for G. Now I need one whole G, not 8 eighth parts of G. So I'm going to multiply both sides by 8. Remember, to make a whole number into a fraction, you just put it over 1. That eliminates those, so I just have now what is 1G, and this is times 8. Many of you are able to get to this step too, which is great, but then a very small population of you then multiplied incorrectly, and you had calculators. 450 times 8, I could probably do this in my noggin, but just to double check, $3,600. Okay, you don't really need a dollar sign here. If you'd like, you can. Now again, here's the step we're not doing. Plug it back in. Substitute it back in. Better vocabulary there, Mr. Jimmy. 3,600 divided by 8 should give me 450. Let's take a look. 3,600 divided by 8 equals, there you go, 450. That checks. 450 checks 450. Next one. Janice spent $325 on clothes. This was 5 times the amount she spent on her 5-year-old brother. How much money was spent on clothes for her brother? Okay, let's take a look. Again, I'm thinking to myself. Spent $325 on clothes. This was 5 times the amount she spent on her 5-year-old brother. How much money was spent on clothes for her brother? Many of you want to go to division to solve this, which is great. But again, I need to use the inverse in my equation. I hear times. I know that's multiplication. I don't know what we spent on her brother. That's the variable. That's the unknown. So we'll call it B for brother. So we go 5 times whatever we spent on brother is equal to what we spent on Janice, $325. And now I'm just going to, here's my equation. That's already 1 point for myself. Hip, hip, hooray. I want to evaluate for 1B, not 5B's. So I'm going to divide both sides by 5. So I'm just left with essentially 1b over here. Divide by 5. I get b is equal to, again, you have a calculator, use it. You can use your head. I like that better, but then check with your calculator. 325 divided into 5 equal parts gives me, poor little brother only had $65 spent on him. That won't even get you a pair of shoes anymore. So that's that. And again, to check, substitute back in 65 times 5 is equal to 325. 325 checks 325. All right. Solving and graphing. We kind of lost our focus here. Solve it the same way that you do an equation, but you have the inequality. So I could just transfer that inequality symbol right here, right now. Now this next chapter might not be able to jump that so quick, but now I want to solve for x. X has to be greater than something. I want to get rid of that 8. I want to isolate that x. So I subtract 8 from both sides. Many of you, or some of you told me that x was equal to 5. Well, 12 minus 8 is 4. So x is greater than 4. Open circle because x is not included in the solution set, and it's greater than 4, so my arrow goes to the right. So that means I could substitute any value in here that's greater than 4, and it'll make this statement true. So 5, for instance. 5 plus 8 is 13. 13 is greater than 12. 10. 10 plus 8 is 18. 18 is greater than 12. Next one. I have z minus 5 is less than or equal to 15. I'm just going to transfer my inequality symbol here now so I don't put equals by mistake. I want to isolate z, so I'm going to add 5 to both sides to get rid of it. Add 5. 15 plus 5 is 20. Z is less than or equal to 20. I will just plot 20 here. Now, it's less than or equal to, meaning 20 also works in the solution set. And it's less than, so my arrow goes to the left. And I could substitute in, is 20 minus 5 less than or equal to 15? Yes, it is, because 20 minus 5 is 15. 15 is less than or equal to 15. Would 10 work? Yes, 10 minus 5 is 5. 5 is less than or equal to 15. Again, less than or equal to, that means that solution is included in the answer set, or the solution set. All right, next one, solve and graph. Same thing in equalities. This is 4 times something is greater than or equal to 52. Okay, I need to evaluate for 1x, not 4 of them. So I'm going to do the inverse to get rid of this 4. I'm going to divide both sides by 4. Going to transfer my inequality symbol over here. I just have x by itself now. 52 divided by 4 gives me 13. This says x can be greater than or equal to 13. That means 13 is included in the solution set. So I have a closed circle. Greater than. To the right. There we go. Next one. K divided by 5. Something is broken up into 5 equal parts. And that's going to be less than 12. So something is less than 12, I know. Oh, no, I can't do that. See? There we go. There's a common mistake. Always be thinking what you're doing. Times both sides by 5. That eliminates this, so I'm left with K. Times that by 5. That gives me 60. K is less than 60. I'll plot 60 now. That means 60 is not included in the solution set. So anything less than 60 will make this inequality true. All right. Last one. This really hurt my 3rd period class. The explanation part. Study the table and use it to answer the following questions. 4 ounces of water, 22 feet. 8 ounces of water, 50 feet. 10 ounces of water, 60 feet. 16 ounces of water, 91 feet. How much water is used to launch the rocket 50 feet? Well, let's go to height. That's feet. Okay, we have 50 feet. How many ounces? 8 ounces. Okay. That was not a problem. We did that really well. Can I spell ounces right? Let's see. There we go. Good. All right, I'm going to scroll this up here. If twice as much water is used, will the rocket soar twice as far? Explain. Well, let's take a look. When I had 4 ounces, I went 22 feet. When I had 8 ounces, I went 50 feet. So, yes, indeed, it did go twice as far. But let's see if that trend continues. When I used 8 ounces of water, I went 50 feet. When I used 16, because 16 is 8 doubled, it only soared 91 feet. Now, 50 doubled equals 100. 91 is not 100, it's less than 100. So, my answer, if twice as much water is used, will the rocket soar? No. The rocket will not soar twice as far if the amount of water is doubled. I know this because when I used 8 ounces of H2O, it soared or climbed 50 feet. But when 16 ounces of water was used, it only climbed 91 feet. I can infer now, that the rocket has a limited capability of height, and that is why as water increases, height will not necessarily double as it did from 4 to 8 ounces. I understand this is involved, but again, you want to up the rigor, you want to improve your writing skills in mathematics just as you want to in language arts, science, social studies, so this pushes yourself. All right, have a great weekend. We'll see you on Monday.